Good morning. The name of this project is 360 Tour as an interactive tool for virtual laboratories, a proposal. My name is Felipe Hernández Rodríguez and my colleague, Nicia, Guillén, Yparrea, both from Tecnológico de Monterrey in Mexico. This study proposes the use of virtual tours as an interactive tool in engineering laboratories in order to increase the student motivation and academic performance. A 360 tour is proposed to learn about the Integrated Manufacturing Systems Laboratory in campus, which has specialized machinery such as CNC equipment, industrial robots, and material handling and storage system. In recent years, due to the increase in the offer of online courses in our institution, such as flexible, interactive, and technological courses, regional courses, flexible digital model, and the new educational model known as Tech 21, and recently, due to the pandemic, there is a deficit in the students' experiential experience in courses that involve the use of laboratories. Virtual learning environments are required to guarantee the experiential experience of the student in those courses that involve laboratory equipment. There are different categories in this technology: 360 virtual tours, virtual and augmented reality, and mixed reality. 360 videos can be used in education to showcase complex scenarios difficult to explain with images, words, or even conventional video. One basic advantage using 360 videos is that the instructor can be on screen and narrate the video, creating teacher presence without actually being physically there, unveiling the opportunity to record observation more accurately. Creating virtual spaces to ensure students remote access to campus learning spaces with the aim of developing competencies and skills for the use of existing equipment in the engineering laboratories. This proposal offers virtual interaction in engineering laboratories. During the virtual tour, it is possible to insert AR elements such as images, links to instructional videos, or visual elements overlapping the machines as a tool to point out their components. These virtual tours show students the distribution of devices and their main features to learn at their own pace the technical concepts. In the first stage, students will have the opportunity to visit the laboratory remotely, learning about the components of the manufacturing system. In this way, they will be able to identify the elements and their interaction. At the same time, they learn about the specific characteristics of the equipment. The virtual tour can be accessed using high-end mixed reality devices such as Microsoft HoloLens or more affordable devices such as cardboard viewers, but with the restriction of no interaction with objects. By the use of a 360 camera and specialized software as Unity, an image study was carried out for the creation of virtual tour, which allows students to have access to the campus manufacturing laboratory remotely. The procedure is not complicated. 360 captures are taken at different points of the space of interest, taking into account the occlusions and overlaps in the views of the images, so that when processed in the select software, a complete view of the elements available in the laboratory is obtained. We named the technique used as spatial distribution of 360 objects for navigation. 360 elements are distributed in spheres over the layout of the laboratory, emphasizing the points where the information is located to be displayed. The interaction with the machines will be developed through links to external tools for the virtual tour. The following images show some captures for the 360 virtual tour, the interaction of some students in the real laboratory spaces, and the interaction with this tool accessed by cardboard devices. The students should be working through this platform to do different kinds of practice tasks. With remote access, students can also self-manage their learning and progress at their own pace without the direct supervision of an instructor. This strategy reinforces disciplinary and transversal competencies that help the integral development of the student. The possibility of generating distance collaboration links with other educational institutions is available. As a conclusion, giving rise to the generation of innovative resources to reinforce learning and encourage motivation towards self-learning, in addition to being a versatile tool for teachers in charge of training in collaborative spaces, increasing the motivation and academic performance of students. We invite you to read the full version of our paper. Thank you for your attention.